Okay, we're going to add some math to our graphs. We're going to start with objects at constant velocity, and then we'll add to this objects at constant acceleration. So what happens when you have the same velocity the whole time, and then what happens if you have the same acceleration all the time. So when you had constant velocity, if you'll recall what we did in the first part of class, on a position time graph, you would have a sloped line of some sort. Maybe it slopes up, maybe it slopes down, and the slope tells me our velocity. So if I've got a positive slope, I'm moving forward, or I'm moving to the right, or I'm moving up. If I have a negative slope, then I would be moving down or to the left or backwards. Okay, so your slope equals your velocity. And so we're going to have an equation that looks like this. I'm going to label all these things for you. Remember that the subscripts are adjectives, so we're measuring position, but we want to know final position. XO is going to be original or starting position. V is going to be our velocity, and T is going to be time. So we'll be using those symbols kind of for the rest of the year. So might as well go ahead and label them all today. And this equation, if you'll notice, this looks an awful lot like the equation of lines you do in your math class, y equals mx plus b. Except that who's written first on my equation, b or mx? The b part, the y-intercept part. So that means slope, we want to line these up here. This would be our y final. This would be our y-intercept. This will be slope. And time is my x value. So it's very much like we do with lines in math class. So hopefully that will help you. So let's start with this. We'll start with some easy ones. Ooh, pen's really struggling, isn't it? I have to remember tonight to change ink cartridges. So we're going to start with some easy ones. And as we get to acceleration, we'll move up to some harder ones. And I'll wait till everybody kind of gets caught up. Because I know it takes a minute to copy. Do I need this? Okay, so how would we answer this question? What is our piece that we're looking for? So if I write all these variables down, what pieces do I have in my statement? Zoom in a little bit. What pieces do I have in my statement? What am I supposed to find? Which one of the letters goes with the thing I'm supposed to find? I'm supposed to find where the car is after 3.5 hours. So that's going to be our X final. So this is the one we're looking for. What's our original position? Well, 0 miles is my original position. My velocity is 50 miles per hour, and my time is 3.5 hours. So now I'm going to fill all that in where it goes. So, sorry. So we fill in everything we know, and we start asking ourselves, how does the math work here? It works just like it works in your math class. Now we got to pay a little bit of attention to the units, because just like in math class, I can't add an x to an x squared. I can't add a square root of 3 to a square root of 5. We have to have like terms. So we have to have like units is going to be one of our ways to tell if we have like terms. Now you may remember you can multiply anything or divide anything, but you have to be able to have the same unit to add or subtract. So what is our final position? Well, our final position is 0 miles, so that doesn't really change anything, right? Whether you add 0 or subtract 0 doesn't make any difference. It only matters when you multiply by it. And then we go, okay, I look at this. I've got 50 times 3.5. 50 times 3.5 is 175 over 1, which is just 175. And of course, feel free to use your calculators, okay? Most of the time I am my own calculator. But sometimes I'm going to ask you to back me up because I'm not exactly sure what the decimal places are. So, 50 times 35 is 175, or 3.5 is 175. And now what unit do we have? Well, we have hours on the bottom and hours on the top, so the unit hours will cancel out and leave me with the unit miles. So I'm 175 miles away from where I started. Okay on that? Pretty good? Okay, let's do another one. And I'll wait. I'll wait to see if there's any questions. Looks like we're all good. Everybody good? Okay. So, Devante was late for work. So he traveled 15 miles in 12 minutes. Let's do this. What was his average velocity? Sorry, Devante, I made you late for work. Next time we'll let you do something fun instead of being late for work. If you work for Nissan in Smyrna, if you're late twice in 1 year, they fire you. End of story. Devante's the guy that used to work at Best Buy and helped me pick good video games. He was cool. Then he got a job working for their Geek Squad at the central headquarters, which was a much better paying job than working as a clerk in the store. So he was funny. All right, so late for work, traveled 15 miles in 12 minutes. How would we use this equation to get that? Well, let's see. X final equals X original plus V original T. I know that his final position, do I know what his original position is? It didn't say. But since he traveled 15 miles, what can I do? I can make one up, right? And then make the other one, make the original position whatever I want to, and then just make sure that the final position is 15 miles away. Does that make sense? So like, if Mr. Trigg wanted to make the starting position 5, he'd make his final position 20. Or if Miss Smith wanted to start with original position 0, then she'd make her final position 15, right? So the easiest one, of course, is always putting in zeros or ones. We like zeros and ones are friendly. So we'll put in a 0 here. So this will be 15 equals 0 plus velocity, which I don't know, and the time was 12 minutes. So 15 equals 12 VO, and this is miles, and this is minutes. So we get 15 miles divided by 12 minutes equals V original, his speed. Let's see, 12 divided by 15 is 1 with a 3 left over, 1.25. .25 miles per minute. What is this in miles per hour? Let's see if we can do that part too. You okay with how I set that up? Anybody have a question where anything went to? Some of you, math is really friendly for you. You feel confident in your math. Some of you don't. It's okay. Just let me know and I'll help. Okay, so let's see what this is in miles per hour. 12.5, whoops, 1.25, whoops, 1.25 miles in 1 minute. Okay, so what's our conversion factor? We want to get rid of minutes. So I'm going to put minutes up here, and I'm going to put hours down here. And what's the relationship between minutes and hours? 60 minutes in an hour. So that would give me 60 times 1.25 miles over 1 hour. So let's see, 60 times 1 1/4 would be 60, 75. So he went 75 miles per hour. Depends on where he was driving that, whether he gets a ticket or not, right? 75 miles an hour on the interstate, probably fine. 75 miles an hour on Sam Ridley, maybe not so much. Assuming you could even get going on Sam Ridley in the afternoons because, right, traffic around here and around there has gotten really, really hectic. Okay, question on that one? What about the conversion at the end? You feel okay doing that kind of conversion? Be okay? Okay. All right. Well, we'll stop there for today. We're going to do some math tomorrow. Or not tomorrow. I'll see you again on Thursday.